So today we're going to talk about equivalent fractions. And to start that conversation, I'm going to ask a question. Is 1/2 the same as 4/8? Now obviously they're different numbers. 1 isn't 4 and 2 isn't 8. But as a fraction, do they represent the same thing? And drawing on what we learned last time, we can draw pictures to see if they are. So let me draw a square over here. I'm going to divide this square into two parts, and then I'm going to shade in one of them. So I've now made a square that represents 1/2. On this side, I'm going to make another square, but this time I'm going to divide it into 8 pieces. So 1, 2, 3, 4, 5, 6, 7, and 8. And I'm going to shade in 4 of them. Now it doesn't really matter which 4 we shade in, but if we pick the right 4, we'll see that we get the same picture. We have the same amount of the total square shaded, whether we divide it into 2 pieces and shade 1 of them, or 8 pieces and shade 4 of them. So these two fractions are equivalent. We can say 1/2 is equal to 4/8, and this is a true statement. But suppose we don't want to draw pictures every time we're asked a question. How can we figure this out mathematically, algebraically? And it all has to come down to common factors. And we learned before that common factors are numbers that can divide other numbers. And notice that the factors of 4 is 2 times 2, and the factors of 8 are 2 times 2 times 2. And so we have some of these numbers repeated. So if we want to reduce this fraction to make our numbers smaller, well, all we have to do is cancel them out. So we can cancel out a pair of 2's and a pair of 2's, and then all that's left is 1, 2 on the bottom. But what number? Does the numerator just become 0? It doesn't. Because when we divide 2 by 2, we get 1, which gives us 1/2. And hence we can say we have reduced this fraction into 1/2. So let's do another example where we are asked to reduce the fraction 4/12. Now, it will be helpful to remember what are the factors of 4 and what are the factors of 12. So we can get 4 by multiplying 2 times 2, and we can get 12 by multiplying 2 times 2 times 3. And if you needed to take a moment longer than I did to figure that out, it's okay. I'm trying to keep the video as short as we can, because it takes a lot to upload. In any case, notice that I have some common numbers that are going to cancel out. So if I write these factors as a fraction, I can just cross out the ones that cancel, and I'm left with 1/3. Now you might like this process, but it means we have to factor every number to see if we can reduce it. But there is another way. So let's take our 4 and our 12. Now, is there a number that we can divide both of them by? Yes, we can divide 4 by 4, and then we can divide 12 also by 4. And what is 4 divided by 4? 1. And then 12 divided by 4 is 3. So we have reduced 4/12 to 1/3 by dividing both the numerator, the part on top, and the denominator, the part on the bottom, by the same number. Let's try another one. How about we reduce 7/12? Why don't you think about this one for a moment? Is there a number that can divide both 7 and 12? No, there isn't. So this fraction is already reduced because there is no number that can divide both 7 and 12. So far, we've only been reducing fractions. But what happens if our question was, write a fraction equivalent to 3/7? Well, 3/7, we can't reduce this fraction, but to write an equivalent fraction, we just pick any number other than 1 or 0 and multiply the numerator and the denominator. So if we just say pick 2, and we have 3/7 times 2 on top times 2 on the bottom, and that gives us 6/14. I said we could pick any number. So let's say we pick 10. Then we have 3 times 10 on the top, 7 times 10 on the bottom, so we end up with 30/70. And so all of these fractions, 3/7, 6/14, 30/70, that's a weird one to say. All of these fractions are equivalent because if we reduce them, we always get back to the beginning, 3/7. And so in this lesson, we've defined what it means to reduce a fraction. We've shown a couple examples of how to do that. And we've shown what it means to be an equivalent fraction. These are just some of the tools we're going to use with fractions, but it's really important to have these tools to help us be able to do more and possibly more exciting things as we go forward. So thank you for watching today. Have a good day.